Welcome everyone to today's webinar. Today we will be talking about connecting data towards sustainability initiatives. If you have any questions during the presentation, please type them into the question box of your GoToWebinar control panel, not in the chat panel. Also, a recorded version of the webinar will be available on our website and YouTube channel within a couple of days. So you will receive an email with the link when it's available. So thanks again for joining us. Now let's have a brief introduction of ourselves first. I'm one of your hosts today. My name is Evelyn. I'm an enterprise asset management strategy consultant. What a mouthful, huh? I have a background in civil engineering, construction management, architecture, building science, GIS, and data science, all derived from my passion for using technology to support sustainable development. We have another host today, Luke. I'll let him introduce himself.
All right, thank you, Eve. Well, hello, everybody. My name is Luke Wing. I'm a performance and innovation consultant here with Microdesk. And my main goal really is to support our Co-Innovation Lab here. And we're really developing sustainability frameworks to help support organizations throughout the world as we're a global organization. I'm also a building performance analysis certified through Autodesk. So if you've been to Autodesk University, we probably have crossed paths in the past. I've been lucky enough to be speaking there since 2015. Eve and I both have some submissions in this year as well. So feel free to go check us out and vote it up, and maybe we can see you again this year in New Orleans. But just before starting, I'll go ahead and give you guys a quick update to who we are here at Microdesk. Once this gets going. So here at Microdesk, we've been innovating project delivery for over 25 years now and steadily building upon our strong foundation, and we are intent on building a sustainable future. So our services range from an array of workshops. We do project support, project management, and lots more. And with over 230 AEC experts that range from registered architects, professional engineers, construction specialists, application developers, and additionally, we have teams dedicated to IT advisory, asset management, and research and development. So we have the vision, tools, and talent to help your firm start to develop and deliver top quality projects. So just real quick, we are officially a 2030 signatory firm, and that really supports our drive here at Microdesk to build upon a culture that revolves around transparency and encouragement with a commitment to sustainability. So our top three priorities, we go by what's called the GUS, and that's for globalization, urbanization, and sustainability. And we understand with those factors, globalization and urbanization being inevitable, the only way we can really build back better is to do this sustainably. So today's webinar, just to update you guys, is brought to you by our Co-Innovation Lab. And we are a part of a really dynamic team here at Microdesk. One of our primary objectives is really help organizations work towards achieving their net zero goals and objectives and other innovative solutions that we look to bridge industry gaps, right? So this team is included of our asset management, our development ops sector, and of course, COIL, which is short for the Co-Innovation Lab. And collectively, we all work together on providing the optimal integrated digital delivery service, right? And we co-develop bespoke plans for organizations on how to best implement net zero, smart buildings, along with any other innovative strategies bridging some of the biggest gaps in our industries today. So with all that being said, let's go ahead and just dive right in. Here's a quick glance at our agenda for today's discussion. We're going to first talk about the definition of sustainability and net zero, along with initiatives that are around the world. Then we'll briefly touch on how that data lives throughout the project lifecycle phases, from the early preparations to post-occupancy and operations. So we'll discuss how to adopt BIM processes to design, build, and operate sustainably. And finally, we'll understand how we can connect all that data to support those initiatives. So without any further postponement, I'll go ahead and pass it back over to Eve, and she can go ahead and start this conversation and really define sustainability and net zero for us.
Thank you, Luke. Before we dive into today's topic, let's look into what is sustainability and what is net zero. These buzzwords are often used in various contexts and different fields. Let's see what they mean in the context of our industry. So what is sustainability? Based on the most adopted definition defined by the World Commission on Environment and Development, sustainable development is the development that meets the need of the present without compromising the future. The United Nations further expressed it through the 5 pillars, including people, planet, prosperity, as well as peace and partnership. Notice that besides the triple bottom line, people, planet, and prosperity, UN also emphasized on the partnership between decision maker and its inhabitants, as well as the peace and governance dimension to ensure cohesion and inclusion in the broader societal context. At the heart of the 5 pillars are 17 sustainable development goals that drive global actions and movement towards sustainable development. In the AECO industry, we can directly or indirectly impact those 17 development goals. World Building Council calls out 9 sustainable development goals attributed directly to the building green. We can improve occupants' health and well-being, provide affordable and clean energy, create jobs and boost the economy, spur innovation towards resilient infrastructure, shape sustainable community, ensure resources aren't wasted, low carbon emission, improve land and sea, and finally, create a strong global partnership. After know about the sustainability, so what is the net zero in the context of our industry? There are various definitions as well for the net zero, depend on the discussed boundaries, time period, and measuring units. But in short, in the context of our climate change and global warming in the AECO industry, we emphasize achieving net zero carbon. It describes the balance between greenhouse gas produced and removed from the atmosphere. In other words, the balance of carbon emission and removal. We can break down the carbon emission into embodied carbon and operational carbon in whole building life cycle. Embodied carbon refers to greenhouse gas emission from the manufacturing, transportation, installation, maintenance, and disposal of building materials. Operational carbon refers to the greenhouse gas emission due to the building energy consumption. Therefore, there are 2 main aspects to achieve net zero carbon. One is to design a very high efficient building that its operational carbon or operational energy can be totally offset by the on-site renewable energy, also known as the net zero energy building. The other is to achieve the zero embodied emission by adopting the principle of reuse, reduce, and sequester when selecting building materials, like construction and deconstruction methods. You can see most sustainability initiatives provide guidelines to address both aspects. For these initiatives, the simply term is to reduce over time. There are several pathways to reduce embodied and operational carbon emissions. As shown here, ultimately, it's all addressing climate change by reducing carbon emissions, and the goal is for all the building and major renovation to be 90% fewer carbon emission by 2030 and carbon neutral by 2050. There are many standards, initiatives, and strategies, both locally and globally, with established frameworks to guide the firms towards sustainable and net zero design. However, the additional information, data, guidance, and indicators are often too overwhelming for the project team, make sustainable development an additional burden. With the advancement of the AECO technologies, now we have the tools and standards can streamline the process by utilizing connected data as today's topic. Now we're going to show you how to embed this design guidance and performance objectives into project lifecycle. So for each project stage, we will show you how to prepare from operation, first outline the strategies for each stages with the standards, tools, and then followed by a selected case to demonstrate the benefits. So where do we begin? It's all starts before a pen even hits paper. Like Benjamin Franklin said, by failing to prepare, you are preparing to fail. It's all about preparation. Clearly defined goals and critical to successfully achieve your sustainability and net zero development goals. Throughout preparation help to set the tones of the consequence activities throughout the building life cycle and ensure they align with the set goal. For the project owner and the operator, this is where they can achieve stakeholder alignment with clear defined goals and set up measurable means for their desired outcome. For the design and construction team, this is the stage where they can clearly define roles and responsibilities and have a consensus about the project data governance means that will eventually facilitate the project verification and validation at the end. For the contractors and manufacturers, this is the stage where you can set up effective digital information exchange means, thereby reducing the risks and cost boosting productivities. In order to do this, first we need to start defining the information requirement in line with the ISO 19650, including OIR, Organizational Information Requirement, PIR, Project Information Requirement, Asset Information Requirement, and Exchange Information Requirement. Oops, sorry, I advanced too fast. And then these requirements eventually can help us to ensure information correctly collected during the project information model phases and eventually establish the asset information model to support the building operation maintenance. So to establish these steps, first we can see to incorporate those connected data, we first need to identify your sustainability goals and what are the key performance indicators you want to measure. This is to ensure the information is captured from the early stage of the design process throughout the building life cycle. Next is to identify the required information. Required information, then you can implement the standards, can facilitate information collect and exchange, and support the information needed for various performance analysis, such as energy simulation and carbon emission estimation, and can help save time and reduce inconsistency. Then we move on to classification mapping. This step is where we can identify the specific valuable sustainability attribute for each building element. This can facilitate information tracking, especially performance-related information. We can then set up intelligent Revit template and establish and implement workflow. This can streamline the data collection and assist the design process. Parallelly, we could develop object libraries, material database to store carbon-friendly materials and their physical properties. This can serve as a single source of truth for design analysis and avoid redundant work and effort. Lastly, is to establish performance threshold that can provide design guidance and facilitate information decision-making. Next, Luke will show you one of the examples to showcase the process and benefits of the preparation stage. Luke, you're on mute if you're talking.
Thank you, Weave. I apologize. Rookie mistake, everybody. All right. So Microdesk, we recently supported a design firm and who often acts as a lead architect within the UK. And this firm has set out goals and objectives for this fiscal year, and their goals were to get ISO 19650 accredited. So here in the Co-Innovation Lab, we kind of go by the line, you start with the end in mind, right? So we conducted and reviewed all their current BIM standards and procedures, and we really crosswalked it with the ISO 19650 parts 1 and 2. And through the auditing process, we identified gaps in their current standards, methods, and procedures. So following that, we co-developed a roadmap and recommendations that would support them for their internal processes and their accreditation journey, right? So these standards really allowed us to manage information effectively within the project team, but also serves as a foundational piece to communicate and collaborate with all the project stakeholders, including the most important, the owner, right? So this led us to developing a tracker for all the BIM-related documentation. So again, we co-developed a naming standard that aligned with the ISO standards. And this really provided us the foundation to implement a consistent naming convention across the board, as well as a compliant, consistent revisioning system for all the resources and models. We also collaborated in developing BIM function matrix, which helps identify the roles and responsibilities for all the projects. We structured the development of all these documents to really limit the repeating or redoing of any work within any of the other documents. No one likes doing anything twice, right? So following this, the firm was ready to go for their ISO 19650 accreditation, and I'm happy to say that they've got certified. And what's the value of this, right? Well, the value of this certification is in their credibility, and it really allows them to bid for new projects. And with uniformed ISO standards, they are consistent not only internally, but with other project stakeholders as well, right? So in turn, this helps them collaborate more effectively with all the key stakeholders, including the owner. And the work we did with Make is a great example of how when information is managed efficiently, we really can increase the collaboration and productivity to meet the goals and objectives on all projects. So in turn, we can effectively adopt those same principles and we can apply them to projects with net zero goals, no matter which industry you're in, architectural, electrical, mechanical, structural. We can apply these same principles effectively. And we can really start identifying these metrics, KPIs, for all these net zero information requirements, right? So we can really start to ensure that we can support the owner's overarching objectives for sustainability, and we're making it much easier and more adoptable for the project. In the UK, they look to standards like BREEAM and REBA 2030 for an example. Here stateside, we're probably more used to the common examples like LEED or AIA 2030 standards. And these are identifying and integrating these construction requirements, or integrating these requirements into like the relevant documents per the ISO. And this allows the project stakeholders to know what they really need to work on from the very beginning, right? It identifies their targets and goals from the offset, and it enables them time to plan to run predictive analysis and be able to review this appropriately at the key data drops that we've set forth in the OIR and the AIR, right? So we're eliminating surprises and we will increase efficiency. I know this seems really overwhelming, but the truth is it really allows us to prepare and plan more efficiently is the bottom line. And with the uniform standards, methods, procedures, we can make it so we're all kind of speaking a common language here, right? Where there's always a disconnect between the design and the field. And how do we get this information, that Rosetta Stone in place so we're all on the same page? When we do that, it's more likely to get adopted and we'll be met with less resistance. And when these bigger conversations around implementing sustainable practices happen, they're going to be more accepted. So all this preparation has really put us in a better position to start to address and actually achieve these net zero initiatives, right? So we've laid them out, and we're going to be talking about them really next in this next phase, which is design. And I'll try to go slow, guys. If I go fast, I apologize. So in the design phase, we really can focus on predictive analysis and the impact of the design decisions. You will want to identify the feasible design strategies with the greatest impacts. For example, some strategies work well in some climates and not so well in others. So we want to determine the parameters that are and the constraints and the criteria that allow us really to streamline our performance analysis. Identifying those goals and metrics, right? This will then allow us to conduct a baseline performance benchmark and against energy and also a life cycle assessments with those required KPIs and metrics in mind, right? With all this upfront work of identifying those metrics and those constraints, we really can begin to utilize this information for the performance analysis itself. And we can then leverage tools like generative design. Once we plug in those needs and wants, it really enables our team and our stakeholders the ability to really visualize the design optimization process. So we are then able to validate and then verify our design inputs against those design criteria that the owner, the designer, or the contractors have in place. And it allows the whole team to make informed decisions based on the three most important metrics, right? Performance, quality, and cost. And finally, we're going to use this integrated data to document your design from your model. And this will help support the construction team and the operation phases afterwards. So quickly, I'm just going to show you an example of a case study. And this is an example of how we implemented those processes for a nonprofit organization named Build Health International, or BHI for short, right? And this project was named Most Impactful Sustainability Project of the Year by Autodesk. And just for some context, BHI's mission is to bring healthcare to some of the most underserved communities in the world, as they are really tasked to build a maternity ward that would help provide dignified healthcare for mothers and their families across West African communities. So in these communities, they suffer from a lack of reliable healthcare infrastructure, high fuel costs, and energy costs. So our team was able to provide BHI with the tools and skills necessary to perform a wide range of passive design analysis, including CFD, to help mitigate the spread of diseases, right? We prioritized local solutions for materials, for labor, as well as when we looked at our ventilation strategies. Our main goal was driving social and economic growth through this community, not just the building, but impacting the community and the people that use it. We're delivering a transformative healthcare and educational spaces to the first time in this region. So what are some of those outcomes from this project? That all sounds great, right? But here's the hard facts. We were able to design and achieve maximum occupant comfort levels while reducing the operational cost by at least $4,000 a year. Our workflow had also decreased the time to perform these analyses from the design team by 90%. This allowed BHI's design team to focus on key priorities for this project and make larger impacts for the community and have more of a circular economy impact and change the lives of these people in this region. So that's all fine and dandy, doing this stuff, the predictive design analysis and this early design phase. But after that, the next step's really to ensure this data is translated into reality. And we all know the construction phase focuses on augmenting the procurement and the construction processes. But what about optimizing the process via construction simulation and real-time tracking and monitoring? The carbon tracking phase extends from previous cradle to gate and now cradle to gate, right? So the focus strategies during this stage are to reduce your construction carbon footprint, ensure your workers' health and safety. We want to look at low emission transportation. We can leverage 4 and 5D simulation, which is augmented reality and virtual reality coordination. And we can even start to include smart sensors, wearable technologies, and really integrate blockchain material tracking. So let's look at how real-time analysis can be beneficial for the construction and for the project outcomes. We first strategize what data we want. How do we want to collect it? And then we'll need to consider exploring strategies applicable to the project goals, whether it's to reduce carbon emission, enhancing a green, healthy construction site, or just increasing safety. Next, we will really utilize logistics and planning to minimize the project's priorities, to minimize the impacts on those priorities, right? Time, cost, and more and more commonly, we're seeing our carbon footprint. So we don't want to go over time, over budget, and we want to have a low carbon footprint as well. The project team can then review and capture those lessons learned against the carbon estimation from the predictive analysis phase and validate it in this construction and operations phases, right? We can then look to the 4 and 5D modeling, which can be used to simulate construction sequencing, which is super helpful when we're identifying the most efficient and cost-effective means for construction and site logistics. AR and VR could be used to help facilitate this coordination and help spot potential conflicts on the job site and prevent idle time, which I know drives a lot of project managers crazy, right? And also can reduce your employees from being exposed to potential hazards and site risks. The next step would be to look at implementing on-site technologies to really track and monitor site logistics in real time, right? And I say real times with hand quotes, but you can't see, but we're close to real time as possible. So the project can utilize on-site tracking technologies such as radio frequency identification, also known in layman's terms as the RFID tags, right? And all these other wearable techs to track material logistics in real-time construction sequences for the workers' health and safety, as well as on-site carbon emissions that support our construction management goals, which ultimately can be captured and visualized in real-time dashboards, which will provide accountability to the field and to the design team to help meeting the owner's requirements and internal tracking of the organizational goals, such as BIM standards or waste reduction, right? Finally, we must verify and validate our data and our analysis to ensure construction quality for the owner requirements and make sure those requirements are being met and not just meeting those expectations, but sometimes even exceeding those, right? We probably, and probably most importantly, in my opinion, is that we need to evolve. We don't just keep recycling the same inefficiencies, but we need to capture lessons learned and implement these on future projects and optimize our process for the future. We should never be stagnant and say this is the way it's done and that's how it is. We need to always be open-minded and look to grow and achieve better. So quickly, just to show the outcomes from the construction side, I just want to share how BIM can be leveraged in a huge impact on a residential building. And we're taking information from data from 2D notes in the field and verbal agreements, which are the worst, to really be coordinated in the cloud environment and help organizations, which I'm sure we're all familiar with. The Rochester, New York, Flower City Habitat for Humanity. Now, they utilize cloud-enabled BIM and laser scanning for building and rehabilitating residential housing, right? So the habitat fosters tangible evidence for decent, affordable shelter, creating long-lasting and life-changing impacts for families and communities. 3D BIM coordination was required on Child Street as the proof of concept for this project. And over 1,000 square foot property contained 1 bedroom and 1.5 baths. And the abandoned house was covered in asbestos and needed to be fully remedied before remodeling could even take place, right? So the Habitat for Humanity decided to take the first step in digital construction journey by employing BIM and laser scanning technology to really streamline the building lifecycle and allow for project documentation to be stored in a single accessible format. And this provided BIM services to help execute and design construction process that was able to house and renovate more people in a single year. Also training and leveraging the BIM technology for the employees and upskilling the community. So you can see how the technology and how the data was really able to inform the construction team, optimize their process, and help and impact more people. I'll go ahead and pass it back on over to Eve, and she can discuss how this information is carried over to the operation stages and really utilized to be most effective.
Thank you so much, Luke. And finally, all the previous effort lead us to a better position during the operational phase, focus on monitoring. Our focus here is to streamline data transition, enable business intelligence, and enhance maintenance and operation. The goals are to incorporate various activities to maintain and operate the building efficiently as intended in terms of the energy consumption, occupants' comfort, occupants' well-being. And these all set up the standards all the way from the beginning. And now, how do we implement these steps during the operational phase? Let's see. First, we will identify monitoring targets that can ensure performance quality. What are we going to monitor? Then we will develop a facility management model on top of the open source platform that to accommodate the different FM stakeholders focus area. We then will configure sensor data and key performance indicator monitoring to enable real-time performance monitoring and real-time human building interaction feedback that can capture how the building is actually used. This collected data can then fed into the AI-enabled business intelligence for asset condition prediction and forecasting, or even more, we can control the building effectively. Subsequently, developing some level of a digital twin, all in all, give owners the ability to save time and cost while developing resilient business model, making positive impact. Let's take a look at a level 2 digital twin case and how it benefits from the connected workflow. So this case is a part of the pilot initiative to transform the traditional use of the BIM to support operational and maintenance. The Neuroscience Health Center of Stanford University is a 92,000 square foot facility that opened in early 2016 with a 21 neuroscience subspecialists along with the PET MRI machine and an autonomic laboratory. Prior to this initiative, the facility management staff used traditional methods to address shutdowns, respond to the work orders, and address other facility management issues, which took a tremendous amount of time to looking up the technical specification and structural information required. The BIM models during the design and construction phases were not utilized for the facility management, and therefore, there's a lot of time and effort were wasted during the handover process for manual data input, collecting asset information, and that could have been directly migrated from the product information models. This disconnected data was identified as the main culprit that can be pivotal driver in increasing operational efficiency and improving patients' care and safety, further reduce daily operational maintenance costs. As the technology and process advisor, Microdesk, we provide a data migration plan and BIM for FM guideline for design and construction. We also conduct 7 different use cases to determine whether it could increase ROI via connected data workflow we provided. We use our 2 purposely built solutions, AECO and ModelStream, to facilitate the data management and migration from the BIM to their computerized maintenance management system. AECO is a cloud-based data dictionary platform that allows the owner to specify the asset information and requirements, so the design and construction team can collect that information accordingly during the design and construction phase. It helps streamline the handover process and transform the project information model into an asset information model smoothly. ModelStream form the bridge between BIM and CMMS, so BIM information can be smoothly migrated to their CMMS system without manual input. So these technologies and strategies that we set up create a lot of benefits. So what can we see here? We observe both direct and indirect benefit among these all use cases we implemented. There was a 98.5% reduction in the time needed for the asset information entry and updating. It's up to like 1,061,600 hours time save. And over the 5 years of period, the projected cost per patient day is reduced by 4%. The time associated with the event for regulatory compliance was decreased by 50%. There is also an 80% time reduction to address major plumbing leak by utilizing streamlined data. There is a 68% time reduction, which is 35 hours to address the structural and fire safety issues. Also, the communication between system engineer and field staff also streamlined. There were 60 to 70% reduction in time spent on shutdown requests that result in an increase in the work hours available for other tasks. A 4.5% decrease in cost was also realized in the engineering maintenance environmental health and safety and facility management department. This case merely shows the benefits of a level 2 digital twin capabilities. Imagine what more it can bring when connecting with IoT sensors and then AI-enabled analytical functions to the plate. Now we've gone through each stage of the building life cycle and outlined the steps, strategies, and tools that you can use to connect the data to support various activities for your sustainability goals. Let's review the complete picture and strategize to capitalize on these information with the end in mind, as Luke said. Look these sustainable and net zero development goals and objectives on the bottom. Their information needs to be tracked from the design intent through the operational stage and ultimately the end of the project lifecycle. Due to the interoperability issue or disconnection among different collaboration platforms and disciplines, several data were lost in transition. That introduced a lot of time and effort wasted in data organization and re-inputting. According to the report from NIST, inadequate interoperability costs around $15.8 billion annually in U.S. facilities. 2/3 occur during the operational and maintenance, where more than 80% of this time is spent locating pertinent information. Now we have the technologies and tools available to streamline these data and bypass the interoperability issues. We can efficiently turn data into information and information into insight. So let's review what strategies this data can support us throughout a project lifecycle. Here we present you with a high-level roadmap to support your sustainability development journey. The advancement of building technologies and international standardization workflow makes the sustainable and net zero development goals within reach. With the predetermined sustainability goals and connected data and information can help optimize the project from the outset, such as support the geometry configuration and material selection during the design phase, help lower carbon material and construction methods that optimize procurement and construction, facilitate the data transition and migrate during the project handover stage, link the sensor and monitoring dashboard to enable business intelligence that eventually optimize the maintenance and operation for a healthy and efficient built environment. An integrated design, construction, and handover workflow, along with early preparation for desired adopted strategies, play an essential role to make the project successful. An early throw-out plan and project standards are crucial to facilitate leverage these technologies to achieve various sustainability strategies throughout the building lifecycle, especially now under the global joint force commitment and pressing environmental issues. The path to net zero is no longer an option, but a necessity. In summary, information is the key, and effectively connect all the data as the critical path to achieving your sustainability development goals. By developing a plan for your data's lifecycle early on, we can begin to fully embrace the power of digital tools without being hindered by fragmented, scattered, and ambiguous data. I will hand it over to Luke and welcome you to join us to co-develop the journey throughout the digital and physical asset lifecycle and co-investigate your project's performance, carbon impact, occupant comfort, and wellness.
All right, thank you, Eve. I appreciate that. And so just a quick reminder, guys, today's presentation was brought to you by Microdesk Co-Innovation Lab. Our Co-Innovation Lab is a formula driven by co-research and co-creation. We are committed to unlocking new and innovative solutions and strategies, and our aim is really to develop value and create impact. So as we generate solutions that drive real transformation, we invite you guys to join us and reach out. Reach out to us with any questions or any interest that you guys may have. We know we've kind of spoken at a very high level today, and we've been touching on trends that we are seeing as a current industry trends. And I really don't like using the word trends, but we're seeing these trends become very rapidly becoming reality. And we believe now is the time to really investigate and understand and implement these strategies. So you're ahead of the curve and not playing catch up when it becomes when these requirements become a demand from your owners or from municipalities as well. Myself and Eve are both on Twitter and LinkedIn. Our information is on our introduction page as well. But if you want to know more and discuss what's possible for your firm, or just understand where your firm is at and what it would take to start this journey, please reach out to us. We would love to take this time to discuss opportunities and, to be frank, just nerd out with you guys or anyone regarding sustainability and data. I know we've gone over quite a lot today, and it's a lot to take in, but just take this moment now. We have about 15, 20 minutes left, and we would just like to open the floor for discussion. Eve and I would probably be more than happy to take or field any of the questions you guys may have. And again, we'll just thank you guys all for joining today. We appreciate it. So by all means, floor is open. Do we have any questions?
Everyone just too overwhelmed by the data.
That's what it must be.
I know.
Guys, feel free to unmute yourself or type in the chat. We'd be more than happy to kind of clarify anything we went over. It is a lot, and it's a lot to cover. This could almost be 3 different webinars in itself, so no shame in asking. It looks like we have a question mark pop in. All right. How are you taking into account thermal bridges? So for thermal bridging, you want to use CFD technology. You want to do a thermal analysis. There's softwares out there to do this as well, but currently we're using the CFD product or Rhino and Grasshopper. You want to make sure your materiality has the correct thermal conductivity and that you're doing your thermal analysis throughout the building. So main thing, canopies, those structures that connect back from exterior to interior. It's always an obvious place to check those. Look for the thermal bridge solutions. There's like I think it's ISO shock absorb. Those are always great. And then when you're talking about, if you're talking about in the wall for like framing factors, there's the software from the like Insight, and a lot of these energy analysis softwares will take that into account when they're sending it up to Energy Plus or DO2. I hope that answers your question, sir. All right, don't see any other questions coming in. Let me see. Oh, there's one more. How will you account for thermal permeability of these assemblies? So when you're in Revit environment, when you take a look at your materials, you can add these thermal assets in there and adjust them accordingly. I typically will Google a lot of this information or use a database, a trusted database. Revit does not come out of the box with the proper thermal assets all the time, and they will need to be added and modified and checked just to make sure. If you're doing detailed analysis, if you're doing schematic analysis, the tools have options for using what's like an ASHRAE baseline, or you can customize your assemblies and make sure that their thermal values are correct and input those into the analysis as well. I hope that answered your other question. Yes, sir. Perfect. All right. I don't see any other questions. If there are, if that sparked a conversation, by all means, guys. Oh, we have one more. And I closed it somehow.
So the question is, what lifecycle assessment tool are you using? So we typically work with our clients depends on their existing tool sets and workflow. And for specific like Revit, and then they want to do quantity takeoff, there are several approaches. We can either building embedded scheduling tool within Revit to calculate a carbon with the dictionary available. So that's one of the approach. And if you set specific proprietary tools, we explore the EC3, Tally combination, as well as like one-click LCA. So again, this depends on the clients and what level of the complexity of the assessment they want to do. So there's schematic design level of like massing calculation, as well as very detailed long-term lifecycle tracking that can incorporate into the cloud dictionary management that we introduced earlier.
Yes. We have another question in. Eve, I'll kind of point this to you too. Do you also assist clients to achieve LEED or WELL certifications?
So currently we help our clients with not certification, but we help them in terms of the technology and then using technology to get those data from their model. So that's kind of helping if that's the way, since there are several like performance driven goals like LEED and WELL, they're targeting, for example, the energy use or material collection, they need to have certain carbon emission, and those can be very well embedded in the Revit template to collect those data early on and set up the standards. So it's essentially a key that what we're talking about today is to establish their goals that they would like to hit those target criteria or indicators, and then we help them to build those parameters, and then so they can collect those information throughout the project lifecycle.
Exactly, that's a great point, Eve. It's very similar to the ISO certification. We wouldn't actually be doing the certifying, but we would be making sure you're set up in order to certify and get certified. All right. Do we have any more questions? I think that's 3. We have a couple people still hanging in. And guys, there's no such thing as a silly question or something that you may feel that might have been answered. Sustainability is a huge topic, like we said. We try to digest it and break it down for you guys, but it can go in so many different directions. And there's so much clarification that's needed. So we're always still learning. Even I learn every day something new. So by any means, any question's a good question.
Yeah. So thank you again for participating today's webinar, and feel free if you think about something that want to brainstorm with us. Reach out to us anytime. I think Luke and I are always welcome for new ideas and then make the whole process work together. I think we need to work as a team globally to push this forward, since there's so many different aspects in this topic. So we will wrap today's webinar and hope you guys have a great rest of your day, and hope to chat with you soon.
Absolutely. Reach out, everybody.